All right, let's go for it here. So looks like we have a square bottom. So the bottom itself is going to look like this. And then for the pool size, if you sort of want to take a look at it, so pools are going to be like this. Let's see if I can sort of at least draw it a little bit here. So it looks somewhat, looks like we have that bottom that's X, then we have the X, and then we have H, because that's the side of the pool, that's the height of the pool that's going to be there. All right, so I guess we should start with the cost equation first. So the cost equation for us is going to be, well, so for the bottom, it's going to be let's see if it's $2, and I'm going to put it like this here, for the bottom, plus it's going to be $5 for the sides. Okay, so we're getting somewhere here, because we started off here. So for the bottom, we were looking at area though. So now let's come back, let's look at area here. So for the bottom, when we get the area here, this is x squared. So that's cool, we're getting somewhere here. This is going to 2 times x squared. All right, for the sides though, notice we're going to have, the bottom's taken care of. So we have 1, 2, 3, 4 sides. So what's going to happen here, it's going to be 4 sides of, we got to think about what the 4 sides, each of the sides are actually going to be x times h. So each of these sides is going to be x, because that's the bottom, or the length times the width, or base times the height. We have 4 of these, so really what we have is we have this. All right, simplified. Down we have 2x squared plus, looks like 20xh. Now, what we're supposed to do is write the cost as a function of just x only. So we have to somehow get rid of the h variable here. All right, so this guy is the one that needs to go right here. We have to somehow substitute that h variable. How do we do it? Well, we do it by volume. So we think to ourselves here, the pool is built with a square bottom. So I'm thinking the volume of anything is length times width times height, and here we have 289, and we're going to go x times h. And so we have here is a, really in a sense, a correlation or a function in terms of x and h. Okay, what we really want to do is substitute the h variable in there. So we're going to divide both sides by x squared. So now we have a relationship between x and h, which is this right here, and let's substitute. Let me change color here. And for the final answer, let's go for it here. 2x squared, looks like it's going to be 20, and the x is still want to be there, but we are going to put in 289 over x squared, and then we are going to simplify. Equal to, looks like 2x squared, and getting a little calculator out, I got myself 5,780 over, now the x's are going to cancel themselves. This x here gets canceled with this one a little bit, becomes a 1, so then we're just left with x on the bottom. So there it is, there's your cost equation just in terms of x, no matter how large x is, and the height is going to come down proportionally. So the bigger the bottom, the height is going to go down a little bit here, so as far as cost goes. And so we've built that in. Hopefully that helps.